China has recently unveiled the Jiutian SS-UAV, an airborne aircraft carrier. This new creation represents a significant leap in unmanned aerial vehicle capabilities. The Jutian is designed to carry and deploy a swarm of smaller drones, signaling a paradigm shift in aerial warfare. The unveiling has sent ripples through the international defense community. It embodies a convergence of cutting-edge fields, AI, advanced stealth materials, long-range hydrogen propulsion, and sophisticated drone swarm coordination. This combination makes the Jutian a formidable platform with the potential to reshape military doctrines. Nations worldwide are closely observing China's advancements, considering the implications for their own security. The concept of an airborne aircraft carrier has long been a subject of science fiction. However, with the Jiutian SS-UAV, China appears to be bringing this concept closer to reality. This platform is about creating a persistent, adaptable, and overwhelming presence in contested airspace. The ability to deploy and retrieve multiple smaller drones offers unprecedented flexibility. This development underscores a clear ambition to achieve a new level of aerial dominance. The announcement of the Jiutian SS-UAV highlights a future where unmanned systems play an increasingly central role in defense strategies. This airborne carrier is more than just a new weapon, it is a symbol of a new era in warfare. An era where information, speed, and the ability to project power through autonomous swarms will define superiority. The world is watching as China prepares to test this groundbreaking system, understanding that its success could redefine air combat and surveillance operations. The Jiutian SS-UAV is a colossal machine, designed for endurance and significant payload capacity. Its wingspan is estimated to be around 60 to 70 meters, necessary for its role as a mothership for other drones. The overall weight is likely 20 to 30 metric tons when fully loaded. Powered by an advanced hydrogen fuel cell system, it is projected to cover distances exceeding 7,000 to 9,000 kilometers without refueling. Its operational altitude is designed to be in the stratosphere, reaching heights of 20,000 to 25,000 meters. Flying at such altitudes places it above most commercial air traffic and some air defense systems. The choice of a hydrogen engine offers a high energy density, contributing to the drone's extended range and endurance. This focus on advanced propulsion underscores a commitment to overcoming traditional UAV limitations. These technical specifications paint a picture of a highly capable and strategically significant platform. The combination of its large size, extensive range, high operational altitude, and innovative hydrogen propulsion system sets the Jiutian SS-UAV apart. At the heart of the Jiutian SS-UAV's capabilities lies its sophisticated AI system. This AI manages and coordinates entire swarms of smaller drones, enabling complex, multi-pronged operations. Stealth technology is another critical component, with advanced radar-absorbent materials and a design optimized to minimize its radar cross-section. Combined with its high-altitude operational ceiling and lower heat signature from its hydrogen engines, these features aim to make the Jiutian difficult to detect. The drone swarm capability is perhaps the most revolutionary aspect. It can reportedly carry dozens, perhaps even hundreds, of smaller, specialized unmanned systems. This ability to unleash a coordinated swarm can overwhelm enemy defenses and deliver precision effects across a wide geographic zone. The Jiutian SS-UAV is expected to carry a diverse array of weapon payloads beyond just the drones it launches. The specific payload configurations would likely be modular, allowing the platform to be adapted for different missions. This could range from long-range precision strike missiles to sophisticated electronic warfare equipment. The combination of these features makes the Jiutian a multi-role asset of significant strategic value. The Jiutian SS-UAV is poised to alter the landscape of modern warfare, particularly in ISR. Its ability to loiter at high altitudes for extended periods, coupled with advanced sensors and the capacity to deploy smaller surveillance drones, provides an unprecedented capability for persistent monitoring. Beyond ISR, the Jiutian's capacity for coordinated attacks marks a significant evolution in offensive operations. By deploying swarms of armed drones, it can execute precision strikes against multiple targets simultaneously. The AI-driven coordination ensures that these attacks are synchronized and optimized for maximum impact. A key strategic role for the Jiutian SS-UAV will be its ability to coordinate with other military elements. It can act as a crucial communications and data relay node, linking air, ground, naval, and even space-based assets. This network-centric approach enhances the overall combat effectiveness of joint operations. The introduction of such an airborne aircraft carrier fundamentally changes the calculus of power projection. Section 5, a new contender, Jiutian versus US UAVs. When comparing the Jiutian SS-UAV to established US UAVs like the RQ-4 Global Hawk and MQ-9 Reaper, several key differences emerge. The Global Hawk is primarily a high-altitude, long-endurance ISR platform, while the Reaper is a medium-altitude, long-endurance hunter-killer drone. The Jutian introduces a fundamentally different concept, an airborne mothership deploying its own fleet of drones. This allows for a much greater area of coverage and more complex, coordinated actions than a single UAV could achieve. The ability to deploy specialized drones for specific tasks provides a level of operational flexibility that current US UAVs do not inherently possess. However, US UAVs have the advantage of decades of operational experience and proven reliability. The Jutian, being a new system, will face a period of testing and refinement before achieving similar operational maturity. Its complexity also presents more potential points of failure compared to simpler designs. Ultimately, the Jiutian SS-UAV appears to be designed to address different strategic objectives. While US UAVs have excelled in permissive air environments, the Jutian's emphasis on stealth and swarm deployment suggests an ambition to operate in more contested airspace. The competition is not just about individual platform specifications, but about overarching operational concepts and the ability to integrate these advanced systems into a cohesive fighting force. Section 6. Shifting Tides. Geopolitical Implications. The rapid development timeline of the Jiutian SS-UAV is a testament to China's significant investment in military modernization. This accelerated pace of development is a clear signal of China's ambition to close and, in some areas, potentially surpass the technological capabilities of other major military powers. This development has profound geopolitical implications, potentially shifting the military balance of power, particularly in the Indo-Pacific region. An operational airborne drone carrier like the Jutian could significantly enhance China's ability to project power and conduct surveillance over vast territories. The ability to deploy persistent ISR and strike capabilities without relying on nearby land bases or traditional naval carriers could alter strategic calculations for many nations. The Jiutian SS-UAV is not just a military tool. It is a catalyst for broader discussions about the future of warfare and the responsibilities that come with possessing such advanced technologies. To Section 7, Navigating Hurdles, Challenges, and Vulnerabilities. Despite its advanced design, the Jiutian SS-UAV is not without its vulnerabilities. One significant challenge is the threat posed by sophisticated air defense systems. While its stealth features and high operational altitude offer some protection, no system is truly invisible. Another potential vulnerability lies in electronic warfare and cyber attacks. Ensuring the resilience and security of its software and communication networks against sophisticated threats will be a continuous challenge. The sheer size and complexity of the Jiutian SS-UAV also present logistical and maintenance challenges. Operating and maintaining such advanced aircraft will require specialized infrastructure and significant ongoing investment. The economic viability of such an ambitious program is a key consideration, as developing and sustaining a fleet of Jiutian SS-UAVs will be extremely costly. Section 8. Beyond the battlefield, potential civilian uses. While the Jiutian SS-UAV is primarily a military asset, its core technologies could find applications in the civilian sphere. Its capacity for long-endurance, high-altitude flight could be invaluable for large-scale environmental monitoring. In disaster relief, it could provide persistent aerial surveillance to assess damage and coordinate rescue efforts. The advanced AI and drone swarm coordination technologies could be adapted for complex logistical operations. The hydrogen propulsion system contributes to the broader advancement of clean aviation technology. Section 9. Conclusion. The 2025 Test Flight and Future of Air Power. The upcoming planned test flight of the Jiutian SS-UAV in 2025 is a highly anticipated event with global ramifications. This flight will serve as a critical validation point for the advanced technologies integrated into this platform. Observers worldwide will be keenly watching to see if the Jutian can live up to its revolutionary design specifications. The success or failure of this test will significantly influence perceptions of China's technological capabilities. If the Jiutian SS-UAV performs as intended, its impact on global military aviation could be profound. It would signal the operational viability of airborne drone carriers, compelling other military powers to re-evaluate their air power doctrines. The Jutian represents more than just a new type of drone. It embodies the convergence of AI, advanced propulsion, stealth, and networked warfare. Its development underscores a future where autonomous systems play an increasingly dominant role on the battlefield. The 2025 test flight is not just a technical milestone. It is